All right, let's do some more examples of finding derivatives using the definition. Um, this problem, we're going to let f prime of x is limit as h goes to 0 of f of x plus h minus f of x over h. Now, we've got f of x up there, so let's come to the side and work out what is f of x plus h. F of x plus h here is equal to this. I'm going to put x plus h inside of here. And let's see, what do I get? X squared plus 2xh plus h squared plus 6x plus 6h minus 1. All right, so now I've got that. I'll put this in place of f of x plus h. I'll put this in place of f of x. And so we wind up with limit as h goes to 0 of x squared plus 2xh plus h squared plus 6x plus 6h minus 1. Then minus f of x, which is x squared plus 6x minus 1, all over h. And if we didn't make any algebraic mistakes, everything up here, well, everything over here is going to cancel away. So let's see, x squared minus x squared, 6x minus 6x, negative 1 minus negative 1. So we're left with limit as h goes to 0 of 2xh plus h squared plus 6h, all over h. Now, I can cancel an h since everything up top has an h in it. So this h goes, these h's cancel. This cancels one of those. So I'm left with the limit as h goes to 0 of 2x plus h plus 6. And now I can plug in the 0 for h, and I get 2x plus 6. And that's my derivative. All right. You might want to give this next example a try before you watch me do it. I'm going to do the same thing I did before, except I'm not going to write the definition out. We'll work out f of x plus h. Then I'm going to substitute those in, get f prime of x is the limit as h goes to 0 of that minus 16 minus 2x squared over h. I'm going to go nuts canceling things. The 16 and the minus 2x squared cancel. And we're left with limit as h goes to 0 of minus 4xh minus 2h squared over h. I can cancel an h now out of everything. I'm left with limit as h goes to 0 of minus 4x minus 2h over 1, which I'm not going to write. Now plug in 0 for h, and I get minus 4x. And that's my derivative. All right. Let's look at two more on this video. Okay, this one. F of x is 1 over 2x plus 3. All right, so for this one, f prime of x, I'm sorry, not f prime of x. I'm getting ahead of myself. F of x plus h is going to be 1 over 2 times x plus h plus 3. And I can write that out as, let's see, 1 over 2x plus 2h plus 3. All right, so f prime is going to be the limit as h goes to 0 of 1 over 2x plus 2h plus 3 minus 1 over 2x plus 3, all that over h. Now I've got to get a common denominator there, and I'm going to do this by, I'm going to take this, move it down a little bit, and add some space in. That should do it. So I'm going to multiply this by 2x plus 3 over 2x plus 3. And I'm going to multiply this by 2x plus 2h plus 3 over 2x plus 2h plus 3. And when I do that, I'm going to get let's see, 2x. Tell you what, let's don't write all this down. Notice up here, when we multiply this together, we're going to have this is the same denominator as this over here. So what we're going to wind up with here on top, well, we're going to have, first up, ignore the h for the moment. If we just add this stuff together, the denominator of that is going to be 2x plus 2h plus 3 times 2x plus 3. And the numerator, I've got 2x plus 3 over here, and I'm subtracting 2x plus 2h plus 3. So if you think about it, all that's left there is the negative 3. Or actually, no, not the negative 3. The 2x and the 2x cancel, the 3 and the 3 cancel. Only thing left is minus 2h. And we're supposed to multiply this by 1 over h. That's equivalent to dividing by h. So let's cancel. And now I can plug my values in. When I plug in 0 for h, I get negative 2 on top. This is 2x plus 3. And this over here is also 2x plus 3 because the 2h goes away. So I get this. And that's my f prime of x. All right. Last example in this video. Square root of f of x is square root of x plus 5. All right. So f of x plus h then is going to be square root of x plus h plus 5. So f prime of x is the limit as h goes to 0 of square root of x plus h plus 5 minus square root of x plus 5 over h. And now to make this, to simplify this, I'm going to multiply it by square root of x plus h plus 5 plus square root of x plus 5 over the same thing. Now I've got a lot of space here, so I'm going to do something I normally don't do. I'm going to write out all the steps. Let's multiply this stuff out. All right, when I multiply this and this, I get x plus h plus 5. When I multiply the outsides, I get plus square root of x plus 5 times the square root of x plus h plus 5. When I multiply the inside, I get minus square root of x plus 5, square root of x plus h plus 5. And when I multiply the last, it's a positive times a negative, so it becomes negative. And then it's just x plus 5. The radicals go away. Now, underneath this, we've got h times x plus h plus 5 plus square root of x plus 5. And now, again, we can cancel things out. Let's see. This and this are negatives of each other, so they cancel out. And also, you've got over here, you've got x, then minus x, and you've got 5 and minus 5. So the only thing left on top is just an h. That's going to cancel with the h that remains on the bottom. So if I cancel this and this, it leaves me with that understood 1 on top. Maybe I should put the 1 in front here. Doesn't really matter, but if you think of that as a 1h, when the h gets canceled away, the 1's still there. So now I can plug my 0 in for h. And so on top, I've got 1 over square root of x plus 5 plus square root of x plus 5, or 1 over 2 root x plus 5. And that's my derivative. All right, and that's it.